Confidence intervals are used when we have sample data and we want to use that to make conclusions about a population parameter. We're going to take a look at two drive-through restaurants and comparing their average wait time at the drive-through. This is sample data as we're dealing with a selection of randomly selected customers. We want to use this sample data to create a confidence interval or a range that we're reasonably confident the population mean will fall between. Let's start with Burger King. We know in this case that Burger King has a sample of 55, and they had a sample mean of 185.2 seconds. To create a confidence interval, we're going to take the sample mean and subtract the given margin of error of 80.2, which provides us with 105 seconds, and then add the margin of error to find the upper limit. 185.2 plus 80.2 gives us an upper endpoint of 265.4 seconds. The confidence interval can be written in interval notation with the lower endpoint first and the upper endpoint second. Next, let's take a look at Wendy's. Wendy's has a different sample size of 75 customers, a different mean, and a different margin of error. The process is still the same. We're going to take the given mean, 190.3, subtract the margin of error of 72.2 for a lower endpoint of 118.1 seconds. For the upper endpoint, the mean plus the margin of error provides an upper endpoint of 262.5 seconds. This creates an interval of 118.1 seconds to 262.5 seconds. You may notice that these intervals are actually very similar. While Burger King does have a slightly lower end point, the upper end points are fairly similar within about 3 seconds of each other. The interval is an interval in which the population mean wait time is likely to be in between. We have no information about where it lies in this interval, just that for Burger King, the population wait time is between 105 and 265.4 seconds, most likely. Similarly, when we look at Wendy's, the population mean wait time is most likely between 118.1 seconds and 262.5. When we look at these two intervals, they have a wide degree of overlap, that there is a lot of numbers that would fall into both intervals that could be the population mean. Because these do overlap, we cannot tell for certain who has a better wait time, and instead must conclude that they are essentially the same.